By the way. So I don't know how you pray to the number 10. I couldn't tell you. But they did. And then they had like a logo for their little group. Symbol, sacred symbol, called a tetractris. Basically, if you look, it's 9 triangles on the inside and then 1 large triangle on the outside. So it's 10 triangles. You don't have to draw it. But the idea is triangles, 10, all that jazz. So, the legend that I'm going to tell you about has to deal with irrational numbers. We all hopefully know about number lines, right? About the number line?
Yes.
So, what is between 0 and 1? You know, there's half, there's decimals, 1/2, there's 1/3, there's 2/3, there's... Okay, so there are parts between whole numbers. He did not accept them. He didn't believe them to be true. So, one night, or one... I guess it was that night. He broke into someone's house because this person constantly disagreed with him and believed in irrational numbers. So he broke in and slit his throat while he slept to keep him quiet because he discovered an irrational number. This is why I said there are 2 videos. There was a historical video, and then there was a he was a weirdo kind of video. So, all that being said, was he a well-liked person in the community?
No.
Probably not. Probably not.
Wait, is it for sure?
I don't know. He definitely did not believe in irrational numbers. Definitely not. So anyways, he was not liked by all because let's say you couldn't stay silent for 5 years. Were you initiated into his group?
Really?
Probably not. If you were a dummy, were you initiated into his group? No. So there was a group of men who got together and they were mad that they weren't a part of this group called the Pythagoreans. So one day, Pythagoras is teaching at the school of the Pythagoreans, and these men get together and they light it on fire. But good old Pythagoras did not die, not yet. He escaped the building, and he ran. He ran until he came upon a field of beans. This is a super weird part. He was scared of beans. I couldn't tell you what part or what kind of beans, but they were beans. So when he came to a stop, he couldn't get around the beans. The mob came up, obviously found him, and he said, "I would rather die of slaughter than run on beans." And so he did. He died. There's some sort of, in the book, there's some sort of like, his blood splatter on, I don't know, it's something weird. Anyways, so people are like, how did he run away and still get caught up? Whenever you see dates of before Christ, BC, you count down. So 570 to 495, to get to 500, that's 70 years, right? Because you're counting down. 70 and then 5 more years. So he was 75 when he died. Can you envision a 75-year-old running faster than regular age men? Nah. So
there's horses.
That's all I got. I think he just ran out of the building and I don't know.
Why was there?
I mean,
Things.
Because they make fields.
No.
They have fields of food. People eat beans.
Like,
Anyways, see, if you have logistical questions, I don't know. They live in, I don't know what you want to say.
There's no way.
They're fields. Anyways, so this is Pythagoras. Okay, he's a weird guy. But he did make the Pythagorean Theorem very famous. Okay, so we're going to use that today. Alright, so the first thing we're going to talk about is what is the Pythagorean Theorem. If you see there's a box below his face, it is the space you're going to write the Pythagorean Theorem, which is a squared plus b squared equals c squared. Your textbook puts it the opposite way. C squared equals a squared plus b squared. It is literally the same thing, it's just flipped. Same idea. A right triangle is made up of 2 different types of sides, a leg and a hypotenuse. So can anybody tell me where the hypotenuse will always be?
C.
Across Across from the.
This is what I was looking for. Across from the right angle, it will also always be the longest side. Gage is not wrong. Which letter will the hypotenuse always be? C. I just wasn't asking that question yet. All right, so I'm just going to show you why the Pythagorean theorem is the way it is really quick. If you took the side lengths and made them into a square, and a square, and a square, they make a right angle. So when I say they use this for the building of the pyramids, they use this concept, but not necessarily the letters or the formula, if that makes sense. All right, so we're going to talk about Pythagorean triple real quick. So you're going to write off to the side somewhere the words Pythagorean triple. An easy way to remember what a Pythagorean triple is: did Pythagoras like fractions or decimals? He did not. He liked whole numbers. So basically a Pythagorean triple are 3 whole numbers that make a squared plus b squared equal c squared. And I'll show you. These questions will say find the value of x, and then is this a Pythagorean triple? The most common Pythagorean triple is 3, 4, 5. I would also write that down. It's going to be a question. I'll show you why it is. So the most common Pythagorean triple is 3, 4, 5. I assume most of you are planning on going to college, but if you were planning on doing like a trade school, my husband said that they actually memorize Pythagorean triples when they're forming right angles at job sites, and I'll show you how. Okay, so this is the most basic. Here's what this means. Are 3, 4, and 5 all whole numbers? They are, and when you plug them into a squared plus b squared, they equal c squared. So what would be a and b out of 3, 4, and 5? 3 and 4, so 3 squared plus 4 squared equals 5 squared. What's 3 squared? 4 squared? 5 squared? What's 9 plus 16? 25 equals 25, yeah? So basically a Pythagorean triple, there are 3 whole numbers. When you plug them into a squared plus b squared equals c squared, the left equals the right, just like this. Okay, that's all a Pythagorean triple is. We're going to look at some in a minute. Your textbook has a list of them. You do not have to memorize them. Just saying. But if you wanted to look at them. All right, so number 1, find the value of x, then tell whether the side lengths form a Pythagorean triple. So if you're missing a side on a right triangle, what are you going to do to solve for the missing side? The Pythagorean theorem, yeah. A squared plus b squared equals c squared. So the side that's the most important is c squared, which is hypotenuse. So which one of these is going to be c squared? X. Does it matter which one I label a and b? Nah. So we're going to say 81 squared plus 108 squared equals x squared. I highly recommend you have your calculator out because you're about to do one by yourself. These are large numbers. What is 81 squared? 81 times 81. And then 108 squared. Okay. Add them together. So add 6561 plus 11,664.
18,225.
Good. That's what x squared equals. What is the opposite of squaring? Square root. So I'm going to square root. So what's the square root of 18,225? 135. So I answered the first part, find the value of x. Then tell whether the side lengths form a Pythagorean triple. So are all 3 of these numbers whole numbers? Yes. So this is a Pythagorean triple. We're going to say yes. That's all you're doing. Number 2. Again, we're missing a side on a right triangle. So we're going to use a squared plus b squared equals c squared. Which one of these is c? 8, which is the hypotenuse, yep. And then I'm going to call 4b. So when we plug in, we'll have x squared plus 4 squared equals 8 squared. 4 squared is 16. 8 squared is, subtract 16. X squared equals 48. Get rid of the square by square root. And x equals 2 decimal places. 6.93. So, is this a Pythagorean triple?
No.
It is not. You are going to do the last one by yourself for a minute.
On the test of the page, does it matter if we have like c squared instead of putting x?
Well, let's just find the value of x. Sometimes it might say find the length of, and then instead of having x, it would have the name of the side. Like if this was AB. Does that make sense? Good, so which one of these is the hypotenuse? X. So you would say 15 squared plus 20 squared equals x squared. 15 squared and 20 squared makes 625 equals x squared. What's the square root of 625? 25. So you ready? What are all three of these side lengths divisible by? 5. What's 25 divided by 5? What's 20 divided by 5? 15 divided by 5? What did I say was the most common Pythagorean triple? So all of the multiples of 3, 4, 5 are also Pythagorean triples. So if they were all multiplied by 2, what would those three be? 3 times 2 is 6. 4 times 2, 5 times 2. Those are also Pythagorean triples, 6, 8, 10. So this is what I mean by my husband. They actually memorize these. If you know the most basic one, all the multiples of them are also Pythagorean triples. So like all of them multiplied times 3. 3 times 3 is 9. 4 times 3, 12. 5 times 3, 15. And so on and so forth. Make sense? Hope so.
So will we be able to tell that, like, if we see him and we have to do work, like if he asks us?
At least show me like you plugging it in or something. Or write down why you think it is the way it is. Alright, so number 7. From school you biked 1.2 miles due south and then a half mile due east to your house. If you had biked home on the street that runs directly diagonal from your house to your school, how many fewer miles would you have biked? So in geometry, what is the best way to solve a word problem? Draw a picture. So before we do, we're talking south and east. So make sure you know things about a compass. You got north, south, east, and west. What angle do north and south and east and west make when they intersect? A right angle. So right angle, right angle. What do you think our picture is going to end up looking like since we're going over the Pythagorean Theorem? A triangle, what kind? A right triangle. That's your goal. So when we are biking, where do we start from?
Wait.
Where do I start from?
Top.
North.
The middle.
North.
Which location do I start from?
The middle. From school.
Read the, thank you.
Oh.
There's 105 talking. We start at school. Then which direction do we go?
South.
Now we go south. You have to have a starting point. So we start at school. We go south 1.2 miles. We stop going south and then we go east. Half a mile. Okay, so where south and east meet, that makes a right angle. It doesn't look like a right triangle yet until they talk about the next sentence. If you had biked home on the street that runs diagonal. Sorry, we forgot to write home. We stopped at our home. Started school, went south, went east. We stopped at home. If you had biked home on the street that runs diagonal. So diagonal. How many fewer miles would you have biked? So the first thing we need to know, how many miles did we bike in general?
1.7.
How'd you find 1.7? We added them. We went 1.2 and then 0.5. So we biked 1.7 miles. What do we need to know next to know how much fewer we could have biked? So if we had done the diagonal, we why not? Yeah, we're going to solve for the hypotenuse using the Pythagorean Theorem. Are you okay? Okay. So we got 1.2 squared plus 0.5 squared equals x squared. So think of these without the decimals. What is 12 squared? 144. So 1.2 squared is 1.44. What is 5 squared? 25. So 0.25. What is a $1.44 plus 25 cents? $1.69. Take square root, and x equals 1.3. So we could have biked 1.3 miles if we had just done the diagonal. So how many fewer miles could we have biked? We're going to subtract, and that makes 0.4 miles. It doesn't seem like a big deal. I wouldn't flip pages yet. It doesn't seem like a big deal, but probably when you're home or you're tired from school, the extra half mile is not very fun. You're actually going to flip to the back. So the white. Yep. You guys aren't taking the per at the end of the month, the dual enrollment test, but next year you would. So I'm going to teach you how to do this without a calculator because you need to. You're also all very smart, and I have faith in you. Before we get to what we actually need to do, we need to practice this. So go ahead and write these down so we can practice them together. The problems. Square root of 5 squared. So on these, I'm going to show you why you do what you do, and then I'm going to show you the shortcut. Okay? So when something is being squared, what is actually happening? It's being multiplied by itself. So the square root of 5 squared is the same thing as the square root of 5 times the square root of 5. What is 5 times 5? 25. What is the square root of 25? 5. All right, so the S building office. Okay. Here's the shortcut. Think about when we have a problem that looks like this. What do we do to get x by itself? Square root. Why do we do the square root? Because it cancels out the square. They're opposites of each other, like adding and subtracting are opposites, multiplying, dividing are opposites. Squaring and square rooting are opposites. So whenever you see a square root being squared, they actually cancel each other out. So the number that's under that radical will be the answer. Doesn't matter what number it is. So if we had the square root of 1,234 squared, what would the answer be? Every time. So anytime a square root is being squared, it cancels out. The next two are realistically, so when you are allowed to use a calculator, you actually type it in correctly. So I highly recommend you actually look at this. I need you to focus. I'm trying to help you, I promise. What is the difference between these two? Parentheses. Your calculator is going to take everything you type in very literally. What is being squared in this one?
The whole thing.
The whole thing, 2 and the square root of 3. What is being squared in this one? Just the square root of 3. You're going to get a different answer. And if you type it in this way, I've had a lot of kids say, well, Ms. Marshall, that's what I typed it in, and this is what the calculator gave me. The calculator is a machine. It's not biased. It doesn't make mistakes. You know who makes mistakes? We do. Okay, so the parentheses matter. So here's the difference in the answers. We're going to write this out twice. Again, I'm going to show you why it is the way it is, and then show you a shortcut. Okay? So this one says 2 square root of 3 times 2 square root of 3. Whereas this one says 2 square root of 3 times the square root of 3. So the only thing that's squared is the square root of 3 in this one. All of it's being squared in the first one. What is happening between, if you had 2x, what's happening between the number and the letter? It's being multiplied. So it's the same thing when you have a radical. This is the same thing as 2 times the radical. So I'm going to put a dot so you can kind of see. All of this is being multiplied. 2 times the square root of 3 times 2 times the square root of 3. Does it matter what order you multiply in? It doesn't. So what's 2 times 2? 4. And we already said it. What is the square root of 3 times the square root of 3? 3. Because the square root of 3 times the square root of 3 is the square root of 9, which equals 3. 4 times 3 is 12. So if you use the parentheses, you would get the number 12 in your calculator. If you don't use the parentheses, you would get 2 times the square root of 3 times the square root of 3 is 3. 2 times 3 is 6. So you're going to get a completely different answer because you're missing that other 2. All right, so you ready for the shortcut real quick? Okay. So since this is the way you'll need to do it in class, you'll be squaring the whole side. Here's the way to look at it. This is the same thing as 2 squared times the square root of 3 squared. What's 2 squared? 4. The square root of 3 squared is 3. 4 times 3 is 12. Same answer. We can do it again. Pick a number, any number. 5. Square root of 4 squared. So it's the same thing as 5 squared times the square root of 4 squared. What's 5 squared? 25. And the square root of 4 squared is 4, even though that was a perfect square. That was dumb anyways. 25 times 4 is 100. Does everyone understand the concept? You square both pieces. Okay, yes, dear. Okay. Sounds good. All right. So we're going to go back to this. Page 2. We're going to decide if 2 triangles are a right triangle. If they are a right triangle, then a squared plus b squared equals c squared. So we don't know whether these are right triangles. Here's what you cannot answer. It looks like a right triangle, so it is a right triangle. Because some people, I'm not saying you, try to make that a reason. It's not a reason. What you're going to use to decide if it's a right triangle is the Pythagorean Theorem. So, we're going to write it down. A squared plus b squared equals c squared. We're going to see if these side lengths make this equation true. So if this were a right triangle, which one of these sides would be the hypotenuse? Square root of 113. It needs to be the longest side. Okay, that one makes like 10 and change. 10 point something something. So this one has to be C. It doesn't matter what 8 and 7 are. They're going to be A and B. So we're going to say 8 squared plus 7 squared. And we're going to see if it equals the square root of 113 squared. 8 squared is 64. 7 squared is
49.
the square root of 113 squared. 113. I wouldn't make it a decimal. What did you do? I don't understand what you did. Add these together. What's 64 plus 49? 113. Does 113 equal 113? Yes. So then we would say this is a right triangle. That's the answer, right triangle. All right, letter B, we're going to do the same exact thing. We're going to see if a squared plus b squared equals c squared. So which one of these would be the potential hypotenuse? 4 times the square root of 95, good. So that means 36 could be A and 15 could be B. And 4 square root of 95 squared would be C. So again, if you notice, I put parentheses because we're squaring the entire side length. So they do matter. What is 36 squared? It's 1296. 15 squared is 225. I'm going to take this off to the side. It's the same thing as 4 squared times the square root of 95 squared. So what's 4 squared? 16. And then times, what is the square root of 95 squared? 95. 16 times 95 is? 1,520. So add the left. What is 1296 plus 225? 1,520. 1. So do these two equal each other? No, this is not a right triangle. Tomorrow we're going to learn what kind of triangle it is if it's not right. This one would be obtuse. We'll talk about it. Guess what? Super funny. All right, so you're going to take out a sheet of paper.